guys, good morning. Today we're going to learn about something called solving literal equations. A literal equation is an equation that contains more than one variable. So you'll notice like in example 1 it says b plus m equals c, and there's like virtually no numbers. In this one there are none. Sometimes you'll have a couple of numbers, but you'll have more than one variable. So you have to be told which variable to solve for. That means which variable to isolate. So in example 1, it says solve for m. That means you're trying to isolate m. Okay, and then it says in terms of b and c. When they say in terms of b and c, over here, in terms of b and c, they just mean that b and c are going to be part of your answer. So you look at the equation and you say, if I wanted to isolate m, if I wanted to get m by itself, I would want to get rid of the b on that side of the equation. So since b is adding on to m, you do what you would normally do with numbers. You do the opposite operation. You subtract b. And then you draw your line. The b's cancel. M is by itself now. And on the other side, we just copy that subtraction problem, c minus b, going across like this. So this is saying that m equals whatever c minus b is. So there's no like answer. There's no numerical answer. It's just like a math problem that equals that answer. The value of m is whatever the value of c is minus whatever the value of b is. And you're done once that variable has been isolated. Okay, take a look at example 2. It says solve for k in terms of b and w. So I see a k over here. The k is multiplying by b. So to get rid of the b, this time the opposite of multiplication is division. I'm going to divide both sides by b. That way the b's cancel. I now have k isolated, and this division problem, I copy it like that, w divided by b. And we don't write the division symbol with the little 2 dots. We tend to use fractions more to show division. Okay, example 3 is an example of a 2-step problem. Solve for u. So u is over here. First, I want to get rid of the p, the negative p, and then I'll get rid of the negative d. Just pretend that these were numbers. If it was like negative 5 plus, or not plus, but minus, oops. Hold on 1 second. There we go. Okay, minus 2u equals 10. Right? If I wanted to solve for u, first I would add 5. Then I would divide. So here I add p. First comes addition or subtraction, and then comes division at the end. I now have negative du equals, and I copy this problem, r plus p. Right? It's like over here I would have negative 2u equals 10. Now I would divide by negative 2. So now over here I would divide by negative d. So it's like the same problem as what you see here, only here we have numbers. And here we have variables. U equals, and I just copy this division problem, r plus p over negative d. And I'm done because u has been isolated, and that was my goal. Okay, take a look at example 4, sorry. Example 4 says solve for r in terms of s and t. So r is here, and it's being multiplied by 5 and t. When you have a variable being multiplied by more than one thing, you could divide by more than one thing at the same time. We're going to divide by 5t. 5 divided by 5 cancels, t divided by t cancels. That brings my r by itself. And then I do the same thing on the other side. I divide by 5t, and then this fraction is my answer, s over 5t, or s divided by 5t. If you'll notice the next one, example 5, has a fraction in it. We want to like kind of program ourselves whenever there's an equation with a fraction, we want to clear those fractions first. So think to yourself, what's the LCM here? If I only have one fraction, my LCM is that denominator, it's 5. So I'm going to multiply both sides by 5. That divides. 5 divided by 5 is 1. So I have 1 mnk, which is just mnk on the right, and on the left I have 5 times b, which is 5b. Now I can isolate, I'm solving for n. I want to isolate n, so remember I can divide, if it's being multiplied by 2 things and it's all together as one term, I could divide by both parts, divide by mk. on both sides, and I now have n equals 5b over mk, or divided by mk. Okay, we're going to take a look at one more, and this one you can definitely try on your own. Pause the video, try on your own before watching the solution. I'm solving for a, so I want to first move this 4m to the other side and then divide. Okay, first comes addition or subtraction, then division. So subtract 4m, subtract 4m, these cancel. I now have on the left g minus 4m equals 4a, and now I can divide. So I'm going to divide both sides by 4 in order to cancel out that 4 and get the a by itself. A equals g minus 4m all over 4. Now, on the answer key, you'll notice when you do problems like this that there will be two answers. The other possible answer is, since this is a fraction, you really have two divisions. I'm going to highlight the two divisions that are happening. You have g being divided by 4, which is just g over 4. Can't really divide that. And then you have another division happening. I'll highlight that one in red. You have 4m being divided by 4, or negative 4m being divided by 4. When you divide 4m by 4, the 4's cancel, leaving you with just negative m. So the other final answer is that a equals g over 4 minus m. Okay, what you can't do is tell me that the answer is g minus m, because the 4's can't just cross out. They have this denominator is dividing by both parts that you see here. It's dividing by the g and by the 4m. So either answer is okay. If you just leave it the first way, that's fine. All right, so use these examples to help you on tonight's homework. You have 6 problems like this tonight. All right, I'll see you guys tomorrow. Thanks.